All right, so don't, keep that simple. Just take the depth of the water times 0.433 psi per foot. It does, the shape of the container makes no difference. Okay. All right. Now the density and specific gravity stuff, that's usually a set of calculations, where you have to find volumes and do things like that to work with that stuff. Okay. All right. Okay, then we got into this whole stuff here with atmospheric pressure, gauge pressure, vacuum. That's using the chart on the formula sheet. There's a little bit of a chart there. It looks kind of like this. It's on the formula sheet on the left. Okay. And, okay. Now I'll get you a new formula sheet for the test. Does anybody need one to be looking at? The blue one? We're good with that? Looks like everyone's got one. All right. Okay. So on the left there, that chart's right there. Some of that type's kind of small. You might need to bring your glasses. I don't know. Okay. I noticed the road signs have been getting fuzzier for me the last 5 years. So I've written a couple letters to ODOT, but they haven't responded. I don't know. Their paint job isn't quite so good anymore. I don't know what the problem is with that. But anyway, they never respond to me. I don't know why, but they don't. Okay. All right. Now, so that's, that'll definitely, so the pressure and depth of fluid will definitely be on there. The whole stuff with the chart, it might be on there. I've had that on past tests. I don't know. I kind of have to pick from things, so I can't say for sure on that one. All right. Okay. Well depth. I don't know. I'll just put question marks next to this stuff if I'm not sure. That means it might be on there. Manometers. Okay. Maybe. No. Okay. All right. Now, the last chapter, the big one that'll, or the big topic, the big thing, force is pressure times area, okay? So that'll be on there for sure. So the things I'm marking are, they're important. I mean, there's stuff I want you to know. That's why they're going to be on there, okay? So you should be able to calculate a density and use specific gravity. You should know that 1 foot of water gets you 0.433 psi. You should know that force is pressure times area. Now, some of these other topics, we use them, but they're not quite as important. And I can't put them all on a 1 hour test. It just doesn't work. So maybe they'll be on there, maybe they won't. Okay? So we good with that? Okay. So this thing will look a lot like homework, a lot of these problems, same sort of thing. All right, so here are some old test questions that I put on some tests. Okay. Okay, the first one, 3 people are having a contest to see who can use the longest straw to drink juice. Who's going to win? Person on the beach in Samoa, person at LBCC, or person in the Himalayan mountains? Any ideas on that one?
A.
It's A, yeah, because why?
The sea level, you've got the greater atmospheric.
Yeah, there's more atmospheric pressure. That'll push the liquid up higher in a straw. Okay. Okay. The atmospheric pressure is greater. Okay, we got a multiple hydraulic jack shown. We're going to push down at A. Those other 3 pistons will push up. Which piston will exert the largest force? Yeah, D. All right. The reason is the force is equal to the pressure times the area. D is going to have the biggest area, okay? Which one will move the farthest?
B.
Yeah, B, the smaller one, right? Because it's got a smaller area. That fluid moving in a certain amount of fluid moving into that cylinder will move the piston further because the area is smaller, okay? All right. So just a couple kind of random questions that are kind of, you might call them conceptual. Okay. Got any questions on that? Okay, find the pressure in the pipe. The fluid has a specific gravity of 1.21. All right, so what we're going to do here is we're going to take the height, 2.89 feet. We know that 1 foot is 0.433 psi. So that's a unit conversion there, isn't it? Okay. So that'll get you psi, but that's for water, okay? They don't give you that number for every possible fluid. They give it to you for water, and then you can use the specific gravity to figure out how much more or less than water it'll be. This one will be more than water because it's heavier fluid than water. So a certain height of that fluid will represent more pressure than it would for water. That's the idea. So when you multiply that out, you get 1.51 psi. You all right with that? Okay. Okay, the next one there, that's measuring a vacuum. So what we want to do then is use that chart, okay? So this is on your formula sheet, so remember that. The top of the chart is atmospheric pressure, because that's what we're used to dealing with. The bottom of the chart is what I would call a total vacuum. Kind of like outer space. No pressure at all. Okay, we got 7 inches of mercury vacuum. Now the total inches of mercury are 30, so 7 would be right about there. Okay, and then we can come down 7 inches. There we go. Okay, the 7 is negative, and the way it's negative is that word means negative, below atmospheric, okay? So what I'm doing is I'm starting at the 0 point for mercury vacuum, and I'm going down 7. It's out of 30 for the total, okay? So if I take 7 over 30, I get 0.233. So that line is 23.3% of the total. That's where that's at. Okay. So on the other side, I got 76.7% of the total. All right. Now, what I need to know then is what's the gauge pressure. Okay. That's over here. 0 for gauge pressure is at atmospheric. It's right on the chart. Okay. PSIG. And to get to the line, I would come down that far. I also want to know what a water barometer would read. That's on this side. That starts at 0 right there. So I got to figure out what those numbers are, okay? So for the PSIG, what I've got is 0.2333 times 14.7. Okay, because I'm 23.3% of the way on 14.7. Okay. So that's 3.43. And that's gauge. Now that does get a negative because that's reading below 0. Okay. So that's a negative number.
Okay, I said I was.
Okay, we're good? Okay. Okay, 0.767 is times the water barometer. Okay, because water barometer 0 is at a total vacuum, and you go up to the line. So you're on the 76.7% side of the line. So that's 26.1. So you want to look at that chart, draw a line about where your value is that you're given. That's the stuff in blue here. Then figure out what percentage of the total that represents. Once you know that, you can figure out any value that you need. Okay. So, you doing all right with that? You good? Okay. Okay. The next one here, want to find the force on the window. Now I just draw an arrow on there, okay, because that's 6 and 2 more. That's 8 feet down to the middle of the window. That's where I want to be, in the middle of whatever it is I'm calculating here. That's 8 feet down. So what I'm going to do here to find this force is I'm going to take the pressure times the area. So I can get the pressure, because I know I'm 8 feet down, and I know I've got 0.433 psi per foot. So I can find the pressure, the average pressure on the window. I can take 8 times 0.433, and that's 3.464 psi. Okay. Okay. Now, the key thing on this one, I'm running one little bit on this. PSI means pounds per square inch. That's what that means. And the units have to match. Okay. When you multiply things through, you got to watch your units a bit. So what I have there is a window with a radius on it of 24 inches. Half of 4 feet is 2 feet. That's the radius. But I need inches, so it's 24 inches. Okay. So I need to find the area, which is pi times 24 inches squared. Which is 1,810 square inches. with that. And now you can find the force. You can take the pressure times the area. It's 3.464 pounds per square inch and an area of 1810 square inches. Multiply those together. Should get something on the line of 6268 or plus or minus. You see the square inches cancel and you get pounds. So that's the force on the window. Got questions on that? Okay. All right, the next one there, what you want to look at is where the stuff is different on either side. That's in between those two lines, because above the top line, it's all water on both sides. Below the bottom line, it's all mercury on both sides. So what indicates a pressure difference there is the stuff between the lines. So what I'd like to do here would be to figure out what pressure that represents there. Okay. Now the conversion that I've got from height to pressure is based on feet. 6 inches is 0.5 feet. So to convert those fluids into PSI, I want to get their heights into feet is what I want to do. Okay. So what I've got going from A to B is I've got half a foot times 0.433 psi per foot. But see, that's mercury that's being held up there. Mercury has a specific gravity of 13.6. It's 13.6 times as heavy as water is. So instead of having that 2.165 psi that water would have, it's 13.6 times that, 2.94. So A is pushing that amount of mercury towards B. Now B is doing something that A is not also. It isn't as significant because we're not talking about mercury, we're just talking about water. But what B is doing is taking half a foot of water and pushing it towards A. Okay? So we do have to account for that. Now, it's not a whole lot. It's just a little bit because there's just a little bit of water over here that's being held up by B and pushed towards A. And we got to remember to take that away. And that's about 0.22, I think. Okay. I think anyway. Yeah, we'll call it 0.22. So the difference is what we want. So that's 2.72 psi. A is stronger than B. It's got more pressure. So it's pushing that up towards B. So, we're doing all right with that? We got any questions on that? Okay, the last one there is a specific gravity, and that relates a lot to density. So the first thing I want to do is find the volume of that tank. Okay, I want the area of the tank, which is pi times the radius squared. So I'll take 1.5, which is the radius, and I'll square it times pi. 7.07 square feet. All right. So that's 84.8 cubic feet. So I'm going to take the area first, pi r squared, and then I'll multiply it by the 12-foot height. Okay, and that gets me how much fluid I can put in the tank. Okay. Then I can divide the volume into the weight. And I'll get 50.3. Sorry about that. There we go. So that's 50.3 pounds per cubic foot. So that's the density of this fluid. What's that? It is, yeah, we got one more step. Okay. So now what I want to do next is compare this number to water. And the number for water is there on the left, upper left-hand corner. So if I want the specific gravity, what I'm going to do, I'm going to take 50.3 and divide it by the standard, which is water, which is usually taken to be 62.4. Okay. So that's 0.806.
And it does have units?
Oh, no, it doesn't. My bad. Sorry. Thank you. There we go. No units. Unitless number. Okay. And yeah, it's just a ratio is what it is. So these units just cancel out. They're gone. Okay, so we got any questions on any of that stuff? All right, so, I just,
I'm sorry,
yeah,
actually, I did,
sure thing.
on the, going back to the graph one, with the 7 inches of mercury in the vacuum,
Mhm.
once you determine, the percentages on either side, how would you determine which direction you're gonna go for? You go from the, 76, okay, 34, okay, you just take the, actual number rather than multiply, you take it from the, the side that actually has the number rather than the 0, because we multiplied it, just be 0, never mind, I think answer not.
Well, it's okay, it's a good question. Take it from the side that has the 0 to the line.
Okay.
Because you're measuring the actual number, which starts at 0 and then goes to the line.
Okay.
So the water barometer, you want the 76.7% side.
Okay, yeah, okay, now I see that.
And
Okay, yeah, the other one for the, okay.
Zeros up there, you're coming down. So you start at the zeros and go to the line. That's
Okay.
the side you take.
All right, cool,
Is that
okay.
good? All right. That's a good question that comes up. All right. Other questions? We're good? You're okay? All right, so if you're looking this stuff over, be sure that you can do the stuff that I've marked with those little lines. You want to be able to calculate a volume. Remember to use the radius when you do that, right? If you got a circular tank. Density and specific gravity. Do the pressure and depth of fluid. Now this one, there's a couple things I'll mention on this. With this pressure and depth of fluid. The first thing is, if you look at the formula sheet, you've got that 1 foot of water is 0.433 psi. So you convert the depth into feet if you need to. You want the depth in feet. That will, by using this conversion, that will get you psi, okay? So you do not want to convert that depth into inches. It's feet that you want, because our conversion goes feet to psi, okay? Sometimes people get a little confused on that because it's psi and they want to get the depth in inches, but you don't. You use feet, and it's right there on the formula sheet, okay?
Yeah, because that conversion's actually in PSI per foot.
Right, yeah, exactly.
Okay.
And people, again, they tend to overthink it, you know, is I think the problem there. And then the other little bit on that is, if, you know, there's a page that kind of describes some of this stuff. I can't remember what page it is. Let's see if we can find it. But the shape and the size of the openings make no difference, okay? All that matters is the depth. And so keep it simple, page 64. You know, I've got all those different charts on page 64. And the shape of the container doesn't make any difference. It can be as big as Crater Lake, or it can be as small as little teeny pores in the soil that are all kind of connected together. You'll get the same pressure regardless, okay? So it's just depth times the conversion gets you pressure. That's all there is to it. Okay?
And then if it's something other than water, you multiply it by a specific gravity.
Yeah, right, because, you know, a heavier fluid will get you more pressure. I mean, you know, that kind
And a
of
lighter
makes
one will
sense.
get you less.
Yeah, right, yeah.
Okay.
Okay, there's a logic to that, right? And see, you don't want to get a new one of these numbers for every possible fluid and write it down somewhere. They just use specific gravity. You just do it for water and then convert for whatever your
Okay.
fluid is. That's the reasoning behind that, I think.
It makes a lot of sense.
Yeah,
It's a
okay.
lot easier to go about it that way rather than trying to convert everything all through and
Yeah,
around.
yeah, right, yeah. It's just, you know, that's the normal way. There's something called a NIOSH pocket guide. It's a little material guide for responders, and it has a specific gravity of the different fluids they might run into, gasoline or whatever it happens to be. Right? It's very common. All right. What else? We got that. Okay, force is pressure times area. The one thing that comes up on this sometimes is if you got a big window like this, you often measure it, the diameter in feet. You want inches though, because you want the units to match. You got PSI when you get the depth, so you want your area in inches squared, so everything matches and works. Yeah, of course.
Well, not the depth would be to the center of that.
Yeah, it's the middle.
The P min, the P max will be.
Right. You can think of it as being in the middle of the object, or you can think of it as the average between the max and the min. It's the same thing, either way. Okay.
Yeah, I've always found it easier to go to that middle point rather than throwing all that extra stuff out.
I was going off the book goes by P min, P max.
Yeah, I did. I kind of threw in a note on going to the middle because it's quicker. Yeah, it's just one shot at doing it.
That's a lot better.
Yeah. Now, okay. Now, a couple other things on this. Okay, so those are the main topics, right? And okay, so just be sure you got those down. Now, the other thing is show work, okay? Because if I just get a number without any background to it and you bust a number on your calculator, I wasn't there when you hit the button. I don't know. You know, I don't have any idea where numbers come from sometimes. So you got to show me where the numbers come from. You don't have to overdo it. But I gotta be able to look at it and see the flow and how it all fits together and what you're doing. If that happens and you punch a wrong button on your calculator, I'll go, okay, hit a wrong button on your calculator, I'll take a point off, no big deal. But if this number just appears and I don't know where it came from, I grade it much differently. I have to, Okay, so do that in your own interest, see? I mean, there's so many reasons to show your work, One thing is it improves your accuracy of what you're doing. That's probably the most important reason. And your units, But the other reason is, if I'm grading it, I got to see what the heck you're up to, And it's in your own interest to do that, right? The other thing is, if I put a couple things like these on here, they're not going to be, the test will be worth 100 points. So I'm not going to put something like that on there and make it 50 points or something. It'll be worth 4 or 5, Don't worry about it. If you get it, you get it. If you don't worry about it. Just get on to the next one, okay? Don't worry about it, okay? They're not worth a whole lot, usually. Okay? So just pay attention to the points. Most of the points, and this stuff all ties together. I mean, this is an assessment, is what fancy education talk about it, is to find out what you know, okay? And I'll put the stuff on there that you ought to know, and I'll make that worth most of the points. So be sure you can do a density and a specific gravity, a pressure, and that pressure and depth are related, that you can do a little bit of that specific gravity if you need to with that pressure relationship, okay? And be sure you can find the average force, or the force, based on the average pressure and the area, okay? That's the main thing we're covering here, okay? All right. We got any other questions? Yeah.
You need no cards or anything?
No, I just have that formula sheet, okay? So have a look at that and, be sure that you can, you know what the formulas are and where they're at and how to use them. One thing, well, anyway, if, as soon as you get that formula sheet or as soon as you get the test, if there's stuff in your memory and you want to write it down, just write it on the top of the test right immediately when you get it. I mean, that's one trick I've used if there's certain things I want to try and remember on a test. It's just kind of a little trick, but I don't know, for whatever it's worth. Okay. All right. We got other questions? Okay. Call it good? You doing all right?